This afternoon, we're going to start talking about standards. We've got actually three really good presentations I'm looking forward to.
Thank you, Chris. So this presentation is going to talk about JPEG's activities. So I'm actually speaking more as my role as a co-chair of requirements at JPEG as opposed to being a Dolby employee. Let's see how it works. Oh, excellent. All right, so this is a kind of a graphic of the interrelationships between a number of different standards bodies. At the top, you have the ITU, and that, of course, broken down to ITU-T and ITOR, but for the purposes of this discussion, the half that's of interest to us is ITU-T. And underneath them is a group working specifically on multimedia applications called SG Study Group 16. And at the same side, on the ISO-IEC side, you have a joint technology group that's made up of members of ISO and IC called JTC1. And underneath them are a bunch of subcommittees ranging from 2 to 38 right now. And there's, of course, gaps in there as groups come and go. The one that's important to us is SC29, which is the multimedia group, a multimedia applications group. And so JPEG falls under both Study Group 16 and SC29. It's the J in JPEG is the joint group. And likewise, our sister group is WG11, which Arian will talk about it in a little bit, is a group that falls under SC29. So JPEG and Hollywood have had kind of a long relationship, and myself and a few other people that I see in the room here have been responsible for much of that and have kept that going. So in 2004, DCI selected JPEG 2000 as the digital cinema imaging codec. And within a year and a half, a specific set of profiles for digital cinema was published, and that was the JPEG 2000, that's all the fancy numbers there you see, and it was in Amendment 1. And so the sort of geek speak is, it's ISO-IEC 15444 or ITU T800, but we all know and love it as J2K. Soon afterwards, the studios had come up to JPEG and requested a set of broadcast profiles so that they could use this for transmission on long-haul circuits. And so, JPEG immediately launched off to create a set of profiles that met their needs, their requirements, and their use cases, and that was Amendment 3. And then a little while later, when IMF was being formed, people started realizing that the broadcast profiles was a great model for them, but the bit rates were limited compared to what was required in the IMFs. And so, again, they asked JPEG to create a set of profiles that expanded the use and functionality of the broadcast profiles. And that became AMD7, or Amendment 7. Now, just recently, about a little bit less than a year ago, a new revision was published that rolled all of those amendments together into one unified document. And so that's published as ISO-IEC 15444-1, revision 2015, or T800, revision 2015. So in the MXF world, one of the key things that was necessary is the ability to interchange between different production and post-production houses, and plus to deliver that packaging in a unified form to institutions that are distributing this, people who author Blu-rays, the likes of Netflix, Amazon, some of these others. So it had a B2B component to it, where the data is being transmitted back and forth. So it was the interchange component of it and the interchange flexibility of it that gave it its strength. Likewise, in digital cinema, this was sort of B2B, but you can think of it as B2C, except for all the C's are in one building. But essentially, in this case, the JPEG 2000 is located in the cinema release packages, and it initially supported 2 resolutions, but then also additional functionality was added afterwards, stereoscopy, higher frame rates, and so there was quite a nice relationship between SMPTE and JPEG in terms of implementing this stuff. And finally, in broadcast, the broadcast profiles are predominantly used for connections between the OBX trucks or the on-site trucks, the network facilities or regional facilities, and then in some cases, to the local networks. Of course, JPEG 2000 is typically used on fiber lines or dedicated lines as opposed to satellite due to the bandwidth. But the key elements of it is you can transport back and forth some very pristine images that can be edited afterwards. So the common themes here are that a still image format is invaluable for production, post-production, and the distribution communities, mainly because it allows editing. It is also very robust to concatenation cycles. When you code and re-encode over and over again, with codecs that use prediction, over time you have accumulated errors. And then it simplified the interchange between facilities, given that there was one common interchange format. And then it allows multiple versions to be distributed with downstream editing. In particular, what I'm thinking of is the IMF packages that may have multiple languages, multiple edits, where in one area you may not be allowed to show blood, in another one you may not be able to show sex scenes or something like that. So you can have one unified package that has all the edits contained in that package. And JPEG 2000 is the image codec that allows the realization of that principle. So now, moving on to JPEG, the big question here is, should pictures be flat? In the past, image capture, exchange, and display has largely been, on the planet since man began drawing caves, And the question, being presented to the community at large is it time to move on? And if so, what does it take to move on? So we'll try to explore some of that. So when you capture reality, there's a large number of capture devices available out there. And these are ranging systems like LiDAR and some of these other ones, infrared-based systems, stereographic systems, plenoptic systems, multi-array systems, and they can fall in either the bailiwick of professional or consumer devices. I think we've seen a number of these presentations already. And it could be military or commercial. Of course, the military oftentimes drives advanced R&D because they have the money for it, they have the ability to draw large sums of money for low volume. But in the end, you can't create a market just on the military unless you're one of 5 or 6 big companies like Boeing and Northrop and things like that. In order to go out, into the much larger mass market where real defined innovation occurs, that requires a lot more. Something I'll talk about in a little bit. Now, on the display side, this is not right. This is strange. Yeah, okay. On the display side, there's a large number of display devices, and you see that as planar, heads-up displays, stereoscopic displays, multi-view displays, holographic displays. We've seen a couple of examples of displays this morning, and they're all over the place, and new ones are being innovated. This is by no means a comprehensive list. It's just a set of ones that I could think of, or we could think of. And again, they span from professional and consumer, and they could be either military or commercial. But one of the key things is there's no common exchange format here, much like in the capture devices. So if we kind of take a look at what plenoptic representation is, I think you saw a variation of this formula earlier, with the exception of this one here has a time component added onto it also. It's represented by your spatial position, your X and XYZ components, your view line distinctions, 2 angular components, and then your wavelength, what's the wavelength you're trying to capture, represented by lambda, and the time. Nothing in this world is static. There's always a time component to it. And you can see that there's kind of a spectrum of different ways that you can define something, going from less geometry to more geometry. And of course, the data that is encompassed within those can vary along those spectral lines. But now you can always simplify the plenoptic function to parts that fit within the planar array. In a way, you're kind of over-meshing 2 planar arrays on it. And you can drop off the wavelength component because as humans we see RG and B, so we can pick up on RG and B, or in some military applications it may be hyperspectral, ultraviolet, X-ray, radar, some other ones, infrared. And for still images, this is a static snapshot, so the T component falls away also. And you can assume an intensity constant along a specific ray of light. So you can simplify some of the problems that come up with your data capture. Now, if we talk about bringing something out to the consumer world, we have to consider the typical ecosystem, and it's represented by the all too well-known three-legged stool, where you have content generation, content distribution, and content consumption. On the generation side, of course, in Hollywood, we have to focus in on what's post-production, the preparation, and then the eventual archive, because after all, we need to watch Blade Runner yet again 5 years from now, the next director's cut of it. And then on the consumption side, we have to think through the implications of rendering, display, and of course remuneration also. We listened earlier where as an industry, we need to start thinking about how do we reimagine these pipelines for display and rendering. And one of the key things in all of this is the dollars have to flow, because if the dollars don't flow, this business is not going to go anywhere, and this is going to be another 3D or any number of technologies in the past that have dried up. So what's missing in all of this? So we've got capture devices, a whole plethora of them. Each one has its own format. We have a bunch of display devices, another plethora of set of devices, again with their own formats. What we're really missing is what's the common interchange format. And that's going to be crucial to any kind of workflows or content workflows that will enable the ecosystem. So what else do we need? Well, one of the things we need is we need to decide which methods or which proposals or which formats are better than another. What are the advantages and disadvantages of it, at least from a scientific perspective? And there's two ways to do that. There's subjective testing, which generally follows what humans perceive, and objective testing. Now, one of the problems we run into with the subjective testing is it tends to be a pretty long, drawn-out process. So researchers tend to try to go towards objective metrics. However, they, of course, want the objective metrics to somewhat mimic what the human visual system does. So JPEG has quite a lot of testing experts that are involved with them. And the subjective tests are vital for validation. In other words, you don't want to spend 3 years working on some project, come up with something, and then take a look at it and realize it doesn't work. So all along, you've got to periodically look at this from a subjective perspective. And inside of JPEG, there's an availability of test methods and people to develop those, test facilities. They're mixed in with the ITU, Qualinet, VQueg, and then peer review. There's quite a number of experts in here who could take a look at these methodologies and who could take a look at the various tests and the imagery and all of that, and come to a collective understanding of it. Now, we're also looking at new modalities. So we've been doing subjective testing for as far as I know, because I've been involved in some of the early write-ups of Rec 500 for 25 years now. So we understand how to do that with planar systems. But now we've got new ones. We've got, and this is by no means comprehensive, we've got point clouds, we've got light fields, we have volumetric, we have depth-based systems. It's not clear understanding of how to subjectively test those and what any kind of scoring means. So this is something that definitely needs to be explored. And on the other hand, you need the objective tests. A typical subjective test could take several weeks to put together, several days to execute, and then to compile and report the results in more days. So we're talking at minimum a month to several months to execute one test. You can't do that every time that you want to test one small change or technology addition or anything like that. So you have to rely on objective metrics, and objective metrics are typically things that are calculated based on difference images or some sort of delta between two images. Now, subjective tests are very, very resource intensive, obviously, and one of the key things is to develop a good correlation between subjective results, or the human visual system, and objective results. For SDR, this is an example that's hit us in the industry over the last couple of years is, PSNR has been a fairly decent metric to use for SDR images, standard SDR images. We all know that, there's a number of people here who I know have been involved in this stuff And now everybody's going, yeah, well, sure. But within a certain range and a certain set of imagery, it works. It's understandable. What we discovered when we started working with HDR is PSNR does not work at all. In fact, there's almost no metric out there that actually works for HDR. There are a couple of them that have been modeled on the HVS system, and they're a bit on the computationally complex side. However, there are some that are being explored right now, and correlations are being done. And these are like HDR VDB2, VQM, VMET. So there's a few of those that are starting to bubble up now. But that was just an HDR. Now we're moving into a place where we've got these spatial considerations and volumetric considerations. And so this is something that's going to be very important to the success of the industry going forward. So JPEG's some of the most leading experts in the subjective and objective testing in there. In fact, the convener of JPEG is pretty world-renowned for his testing acumen. So this is one thing that JPEG can offer to the community. Now, so let me flip to the JPEG Pleno scope and what JPEG is doing. So JPEG Pleno is targeting a framework that's to be standardized for the representation and exchange, of new imaging modalities, such as light field, point clouds, holographics, depth-based system, all of that. So we're looking at the holistic world, so to speak, both from the literal sense and the figurative sense. So the design principles are that one or a limited number of representation models should be employed as an exchange format. Then a framework with a system architecture, of course, is probably going to be necessary. And we've seen some common frameworks starting to bubble up in these recurring presentations we've looked at. And then specific coding tools for specific modalities. I mean, the world would be wonderful if point clouds and light fields and holography all use the same means of compression or image processing. It'd be wonderful, it'd be a beautiful world then, but we don't anticipate that's going to happen immediately. Also, we have well-defined and useful milestones because we kind of want to, match the commercial world with the standardization world. And then where needed, do backwards compatibility with legacy JPEG. Some of the most powerful extensions of kind of JPEG so far are ones that have had backward compatibility with the original JPEG model because it's ubiquitous. Somebody calculated that there were like tens of trillions of JPEG images out in the world right now. So it's hard to break away from that legacy. So a workshop was held in June of 2015 that covered three basic topics: light fields, point clouds, and holography. And there was a number of interesting papers, and a couple of people that are here I know participated in that workshop. So then this year, in the summer of this year, ICME held a light field image compression grand challenge. And ICME is one of these uber geek conferences that tends to have a grand challenge each year. And it's one thing that they announce about 9 months ahead of time and allows people to come in and do their own thing. It doesn't have to be a standard, doesn't have to be commercially viable, anything like that. But it's kind of, it gives a showcase for things that deep researchers are working on. And this is kind of the generalized model that came up. And as you can see, it's very similar to some of the models we saw earlier. Of course, there's some more image processing specific elements of this, because after all, it's an image processing conference. But you can see that these basic elements are starting to bubble up. And so what came out of that was sort of a generalized architecture that sort of fits in a typical image processing architecture, where you go from generation through conversion, encoding and packaging, depackaging, de-encoding, final rendering, and into the display device. So this is kind of a typical workflow that we all know now. So some of the things that have been looked at are the types of light field capture, because one of the things that seems to be bubbling up quicker than others are the light field capturing devices. So on the left-hand side, you see where you have a number of small sensors, but a large number of them. And then on the other side, you see basically one large sensor with small lenslets to them. So there's two ways of doing the same sort of thing, and this is by no means exclusive. Now, you can actually amplify that model to where you have large camera arrays. I missed Siegfried's discussion this morning, but I believe Siegfried talked about something comparable to this morning. And I know that others have worked on similar principles, particularly when the MPEG folk were working on multi-view. They worked with large camera arrays to capture the video. Now, Howard's done some work in his previous life doing some of the same stuff. So these are all concepts that are not unknown, but our kind of feeling is these ones are the ones that are moving forward at least quicker. Not saying that they're better or not, it's just in order for the standards efforts to get content, to test workflows, do things like that, we're starting to look at this aspect of it. And there's another kind of a breakdown of how you could use lenslets and light fields for capture. So this is the timeline. I'm going to have to look up here because you're absolutely right. It's impossible to read this. So the first version of the call for proposal was drafted and issued earlier this year. A second version is being drafted and will be released in the next week. And so that'll be available for the community at large. And then at the next meeting, at the beginning in January of 2017, will be the final version of the call for the proposals. And it's going to be geared towards light fields for the moment. We anticipate that in the spring of next year, there will be anchor evaluation results. Anchors are sort of the state-of-the-art in any of the MPEG or JPEG technologies, and any new proposals always bounced against that because it's kind of pointless to standardize something that's no better than what you've already got. Then there'll be a submission deadline, will be soon after that, late spring. And then in July, responses will be evaluated, and then the results will be available at that meeting. And then we anticipate in October the first working draft to come out, and we figure in the following year, beginning of 2018, a second working draft will come out. And working drafts are kind of like study texts, things that people work towards. And then the first ballot is what's called a committee ballot, would come out in April of 2018. And then draft international standard, and then IS moving into 19. Of course, this is flexible. If we find that we need more work, or it may get stretched out some, or if we find that there's a number of really good proposals that mesh well together, it may be accelerated some. But this is sort of the target set of timelines and milestones that the JPEG Pleno project's looking at. So the first version of the CFE was pretty broad in scope. It covered all of these various topics, and you can see it's a list of 7 various aspects and ways of looking at things. I'm not just going to read them off to you. And it kind of served to sort of get the community to think about, how do we prioritize what's practical, what's realizable, send messages out to be able to begin collecting data and understanding things, defining what an anchor actually is, what constitutes an anchor in this particular case, and then to begin working on evaluation methodologies, because you kind of need something to work on to test to see if the hypothesis in your test method actually works or not. Now the second one, this is the one that was just issued, narrowed the scope of the first call, and it focused on light field imaging, both in lenslets and dense camera arrays. But then we're not exclusive to that. If people want to come in with sparse camera arrays, that's cool too. We want to focus in on applications, and that's one of the reasons why I'm kind of talking to you guys here, is to get you guys to understand what JPEG's doing, and if you have feedback, want to participate or something like that, to sort of send an invite out to you. And then we want to put out the call and complete the requirements, then collect the various data sets that are available, whether we get them from publicly available ones, which we're finding to be not very good, or either capture some or get some from some repositories that we're unaware of now. And then issue a call for evaluation technologies, and this plays into the whole objective and subjective testing. And then learn the lessons from the grand challenge, the 2016 ICME challenge, and try to collect as much information, digest that information. And then the final one will kind of finalize all of the details. This is the one that'll be expected in January of next year. Again, we'll stay focused on the lenslets and camera arrays, kind of hammer down the applications that we think are the ones that could drive the business ahead of time. And then, finalize the requirements based on those applications. Then go ahead and begin selecting the appropriate anchor technologies. What will be our baseline to test against? And then prepare the evaluation results for the anchors and the evaluation results for the various proposals when they eventually come in. So in summary, JPEG and Hollywood have had a pretty long history of joint cooperation in standards and standards development. And this is in cinema, post-production, broadcast world, so it covers a span of the creative community. JPEG Pleno is kind of a new and exciting field, and we know it is because there's quite a lot of interest being put into it and quite a lot of money being put into it. And there's a variety of different ways that it's being looked at this point, ranging from point clouds and light fields to holography and depth-based imagery. And then a couple of the key things is we need some functional standards, and the key standards here are what's the exchange format? How can both researchers and eventually content producers be able to exchange amongst the various entities? And then we need objective and subjective metrics to go ahead and evaluate how well a content is, how well capture is, how well production is, and how well display is. So in conclusion, JPEG stands ready to work with the creative community on development of some key interchange standards. JPEG soliciting input for effective criteria for subjective test methods. And we welcome the community here to participate as viewing subjects. And then JPEG's prepared to hold ad hoc group meetings in convenient locations in the creative community. We can hold meetings anywhere in the Hollywood area, in the Bay Area. So we're very flexible and we're willing to accommodate the customer, so to speak. So if you guys want to participate in JPEG Pleno, the first thing you can do is you can join JPEG, and you do that through the U.S. national body. And I'm the chairman for the U.S. national body, so you can just send me an email and I can plug you right in. And my colleague, Arian, who's my counterpart actually in the U.S. national body for MPEG. And then you can also participate through SMPTE. I know quite a lot of faces here do participate actively through SMPTE in the communication that goes back and forth. So you don't have the burden of having to go to JPEG meetings, yet your voice can be heard inside of JPEG. And then finally, you can attend some of the face-to-face ad hoc groups as I suggested earlier. So thanks a lot for entertaining this discussion, and I'm open to questions. Yes.
It sounds like you're perhaps heading in the direction of light field data being the common interchange format.
It's not what we're saying at all. We see a common interchange format is necessary for all things coming in. The reason why we're looking at light fields is we feel at this point what's that?
Market pull is there?
Well, not only the market pull, but at least on the capture side, it seems to be further along than the point clouds are in terms of the quality of the content received. So by no means are we saying that light fields will be the base interchange format.
I was wondering if you perhaps, there's lots of GIS data and other types of MRI data, CTI data. I was wondering if you perhaps thought they should be transformed to light field data for a standard format, or
it could be. I mean, we're not sitting here advocating one over another at all. The only reason why we're focused on what we're focused on now is we see that as a low-hanging fruit. If we study, it's analysis or paralysis by analysis, we could study until 2100.
You're starting simple.
Exactly. We're starting on something that's chewable.
Well, maybe it's also fair to say that, JPEG is mostly composed of people that are in the image processing and the video industries, and
Correct.
so it's just not well represented by the medical community, so.
Well, it is, actually. We have very strong ties with DICOM.
Oh,
JPEG
DICOM, that's a
2000
good
is
point.
their
Yeah,
base
good point.
image format.
Yeah, okay.
Yes. Line right up.
I'm an old SMPTE guy, but I've got my credit card out. Don't know about JPEG rules. How many ad hoc meetings might there be here in this area for the next year or so? And when there are real meetings, which I know are all over the world, do they allow teleconference attendee the way SMPTE does? Is there a penalty if you miss too many of the big meetings?
Okay, so JPEG and MPEG are both accredited organizations, so you actually have to join a national body in order to attend. There are rules in the national body. In other words, for you to vote on documents within the national body, it's almost the same as SMPTE, 2 out of 3 meetings and, no more than, 2 missed ballots. They're almost identical rules. For JPEG proper, anybody can go, whether you're a participating member or an observation member. Those same categories in SMPTE apply to the U.S. national body. The normal JPEG and MPEG meetings typically meet 4 times a year, quarterly. However, ad hoc groups can meet in between meetings. So those are actually up to the committee to determine on the fly. When we were doing HDR and working heavily on HDR, we typically had at least one what we call interim meetings, sometimes 2.
And are the main meetings, the big meetings, the counts for ballots and votes meetings, are they accessible by teleconferencing or web meeting?
Typically not, because you can fall into the situation we did last week, where we were all in China, and there was like a DSL line into the city. You see all the nodding heads, and you know who was in Chengdu with me. It was horrible. So we can't verify that there's going to be good teleconferencing anywhere.
Now, are the notes in the minutes of these meetings, are they confidential or are they public record?
Their press releases and the resolutions and things like that, which kind of give you the highlight of what occurred, are typically published.
Okay, but the individual notes?
The internal notes are always internal.
Okay.
Except for members who better show up in person most of the time.
Yeah. Now, mind you, okay, so now don't confuse one project with the large group. So I'll talk about JPEG immediately. So JPEG has about maybe a dozen projects going on at once. MPEG has 50 of them, 60 of them going on at all. And so if you're focused on Pleno, the only thing you really care about is what Pleno's doing. You may not care about security. For instance, I'll tell you quickly about JPEG security. What they're struggling with is European and Japanese rules on having faces publicly available. So they're working on hiding people's faces unless you have permission to see it. Do we care about that? Not really.
But does accreditation or the right to vote on ballots require physical presence 4 times a year someplace far away?
No. Actually, so your qualifications have to do with your national body. Okay, so it's the qualifications that you're required to vote on ballots and things like that come from the U.S. rules, which are identical to SMPTE rules. So in the U.S., we generally have 2 face-to-face meetings, one on the East Coast, one on the West Coast, and 2 teleconferences. Our next one's a teleconference in December. The one in springtime will be face-to-face. Philadelphia, right. So, and then it'll be another typically it'll be another teleconference, and then it'll be a West Coast. We haven't picked that yet, have we? I'll bet I'll get picked soon, because I have a new building.
Yes.
I made the mistake of saying that.
Thank you.
You're welcome. Yes.
I'm curious, from the talk, is the goal to have the full 7-dimensional JPEG standard? Is that what the goal is at this point?
Well, the goal is
Pleno function to have all 7 dimensions,
Including time.
including time. Well, we typically look at time. However, time can be looked at 2 ways. It could be looked at as something that's continuous, or it could be discrete snapshots. For instance, JPEG 2000 in cinema and broadcast and all, those are looked at as discrete images, just like film was.
but is it looking at all 7, or I was just unclear?
Well, we're considering it. I'm not necessarily saying we're looking at it, because remember, we could collapse that function down to the 4 primary ones.
For certain applications.
Right.
Yes.
Thank you. Well, you have invaluable information coming back from these experts and experienced people.
Oh, you flatter us.
Are you going to also open up to the even more invaluable experience of the consumers for these ad hoc meetings? For example, I would suggest including the members of the LA 3D Club in your ad hoc meetings to get their feedback, because that club's been meeting for 60 years and they've had their share of experience.
Yeah, I've actually attended some of their meetings in the past. When you said consumers, I was like, oh, man. Focus groups, they never end up, but no, but I don't consider like the LA 3D Club or the US version of it, I don't consider them to be consumers. I actually consider them to be experts. They do have an expertise that is valuable.
I actually would say that the hobbyists in the group have more experience and expertness than the experts, because they've been doing it longer and they do it with more passion and they find out more about it too.
I agree.
But what you need is like a dentist that can say when somebody says, I have a bad tooth over here, take it out. You need the dentist to know the tooth is down here and that's the nerve ending.
Right.
But yes.
No, but I do consider them, and I personally consider that group a set of experts, because I've actually presented to them and I've actually went to some of their meetings.
Right, and many of them are SMPTE members, but more importantly.
That's how I found out about it, actually, was through SMPTE.
They'll be approaching this subject from a unique perspective that may be missed by the average audience, that may benefit from it but not know that it exists.
Yeah, by all means, I do agree with that. Yeah, so in Pleno, it was in the abstract, so we're not looking at, we're not calling this Pleno because it's strictly plenoptics. It's actually the Latin word for everything. So we're looking at everything in imaging and trying to bundle it all together. It may be a huge, huge thing to do, but we're going to attempt to try to do this because we're moving into this world of volumetric viewing.
One interchange standard to rule them all.
You got it. And only when you hold it up to a fire does it say JPEG Pleno on it. How's it going?
Off-the-wall question, but are there any lessons learned from the audio world?
Well, that's all great if you're going to ask me about it, but I'm a video. I'm one of the, well, I used to say I'm the only video person that works for an audio company, but now we've got about 100 of them. Yeah. Well, one of the things we did learn is, in audio we found that allocentric models work the best. In other words, if you move and turn, your environment has to be relative to where your ears are. So that was one of the few things I learned. I don't know if that makes me an expert in audio or not, but that certainly rang in my head. So.
Okay.
Thank you very much.
Thank you. Okay, I think, Howard, you are next, I think.